All right, ladies and gentlemen, so way back when we first introduced this idea of an integral, we said it represented the area underneath a curve, right? And in this lesson, we're going to build on that idea a little bit and tackle some more complex problems. And this, for me, when I was learning this is where integrals started to seem really cool to me. So what we're asked to do is graph f of x, and f of x is our sad parabola here, and then find the value of this integral from -5 to 0 of f of x dx. And then we're going to shade the region for which this value represents the area. So we're going to actually shade first, right? Because that's pretty easy. So notice our integral goes from -5 to 0. I already made the graph for you. So that area would be, well, it would start here at -5 and stop at 0. Everything underneath that curve. And I do really encourage you to use color here because it's going to make everything a little bit more clear here in a second if you use two different colors for this. So there is my area of f of x. So I'm going to just draw a box around that integral in my color so we remember that that's what that represents. And then we're asked to evaluate the integral. For now, I'm going to use my calculator. We could do this by hand. We will actually do this by hand later, but for now, just for the sake of speed and to remind ourselves how that works, I'm going to use the calculator. So I already graphed both of my functions here. We're going to use the line here in a second. And let's see what we had. So my red function, my parabola, was my y1, so I'm going to do I'm going to do math, and then 9 is my integral, and we wanted from -5 to 0, and my function was y1, and we want to integrate it with respect to x, and that value is 24.16. I know that that happens to be a fraction. I'm going to write it as a fraction here. Just really for the sake of being precise. So the integral from -5 to 0 of f of x is 145 over 6. And then we're asked again down here to do the same thing with g of x, which is our linear function. So I'm going to make that blue. And then again, we're asked to shade the region for which this value represents the area. And that would be, again, from -5 to 0 underneath the curve until we get to the x-axis. So notice we have some overlap here, right? And that's intentional. And then we're asked to find the value of the integral. Again, we could do this by hand. I'm going to do it on the calculator. So I'm going to use the same integral expression. I'm just going to copy and paste it this time. But instead of y1, my linear function was y2. So I'm going to change it to y2. And I get 13.75. Again, I'm going to turn that into a fraction. And it's 55 over 4 I get. And then the question is, what would you do to find the area of the region that is located in between the graphs of f of x and g of x? So that region that it's talking about would be this region here, right? So it's not a nice shape. I couldn't use like pi r squared or something to find this area, right? But let's think about that for a second. I know the whole area from the parabola all the way down to the x-axis, and I know this area beneath the line, right? So what would I do? Well, I would be like, okay, I want the integral from -5 to 0 of f of x. I want to take that, and I want to subtract the integral from -5 to 0 of g of x. Because the area between the curves would be the difference from the total minus like this little piece on the bottom here, right? So that would be 145 over 6 minus 55 over 4, which again, we could do this by hand. I'm just going to be a little bit lazy and evaluate on my calculator, and I get 125 over 12. So that's the area between the curves. Okay, so anytime we're asked to find the area between the curves, this is what we're going to do. And notice what this allows us to do is find the area of a pretty complex shape. So it's the area between a parabola and a diagonal line. So this is like the most complex area problem we've ever done in our life so far. Now, we relied on our calculator to do this, but we could actually have done this all by hand because we have the integration skills to do this. That's what we're going to do here on the next page, right? So here's our definite integral. And I'm going to rewrite it here using our two functions, right? So this is exactly what we did in the previous page, but now we're doing it by hand. So it's the integral of negative 1/2 x squared minus 2x plus 4 minus, and careful with your algebra here, parentheses, 1/2 x plus 4. So we're subtracting all of g, and this is all with respect to x. And I'm going to simplify this algebraically before I ever try to integrate. So I'm going to look for like terms, and I have, very conveniently, my 4's cancel. And then negative 2x minus 1/2 x is negative 5 over 2x dx. And we still haven't integrated yet, so I'm going to keep writing that symbol until I actually take the integral, which will be now. Right? So I'm going to do an antiderivative, which means I'm going to add to the exponent. And this is a great opportunity to kind of practice these skills. So I'm going to add to the exponent. I kept my negative 1/2 the same. And I'm going to divide by the exponent now. Because if I were taking the derivative, I would have done the opposite. I would have ended up multiplying by that 3, and I want to cancel that out now. Okay, same thing for negative 5/2 x. I'm going to add 1 to the exponent. And then I'm going to divide by the exponent, the new exponent. And I'm evaluating that from negative 5 to 0. I'm just going to start to simplify. And what this notation means, right, is I plug in 0, and then I subtract what I get when I plug in negative 5. And I'm going to PEMDAS it. I'm going to work from the inside out, so do my exponents first. And here, if I really commit to the no calculator thing, I'm going to make a common denominator, right? So I'm going to multiply my first fraction by 2 on top and bottom, and then my other fraction by 3. What does that get you? 375. And then I get negative 125 over 12, which again is just 125 over 12. So same thing as we got on the front. This one was kind of annoying because it had all these fractions coming up, but it is important to be able to start to evaluate some of these integrals by hand. So as you get to the practice, you will see some are definitely calculator problems. For example, this one says use a calculator to weigh. And then others are asking you to integrate by hand. So make sure you tackle those the way you're being asked, because it's good to practice both, and you may have to do both on the mastery.